Hello everyone, welcome to my YouTube channel. So in this particular session, I'll talk about binary search, which is a very interesting application of recursive approach that we have discussed in our previous session. So basically, in order to demonstrate you whatever concepts we have studied in our recursive approach session, I just want to show you the application, which is a very interesting application in case of a searching algorithm, that is binary search. First of all, the very first thing which you should understand is that whenever we are applying a binary search algorithm, it is applicable for basically a sorted array. So whenever we are providing a sorted array, what does that mean? That array follows a pattern which is either in ascending order or in descending order. I'll tell you the logic behind that as well, but as of now, just consider that this is the major prerequisite to understand the binary search. So binary search is applicable only to those arrays which are sorted in nature. For example, we are given an array like maybe 10, then 20, then 40, then 50, and then 70. And we know that every array has its own index number. So it will start by default from 0. So it will be 0, 1, 2, 3, and 4. Now here if you will see, for example, the element which I want to search for is suppose is equals to 50. Okay, so I want to search for an element whose value is equals to 50. So as an output, what I am expecting is that my array should print the output as 3 because 50 is present at the third index. That is what I am expecting as an output. I am pretty sure that everyone is able to understand this part. Now here if you will see how basically this binary search will work, try to understand that part. Now, as I told you that binary search, we will try to do the implementation using the recursion approach. What is recursion? Now everyone knows. And that's what I want to show you here. Here, if you will see, binary search is an application of what I can say the concept of divide and conquer. So binary search is an application of the concept of divide and conquer. What does that mean? The simple meaning of this algorithm is that first of all, we'll divide our array into halves until or unless we will reach to some small problem. The similar kind of approach you have already, I hope, can have seen in my merge sort example, where that is also an application of that divide and conquer. So where if you remember, we created one recursive tree. We have started from the root node and we keep on dividing the array into two halves until or unless we reach to a final, I would say, small problem. In this case, when I'm talking about a searching problem meaning is that you have been provided a key or user will provide some key and we have to look that is that element is present at some index or not. If it's not present, in that case, it can return -1 or some kind of error message. It can generate that whatever element you're looking for is not present in the array. But the point is that if it is present in the array, at what particular index it is present. That's the key concept that we have to find out in our given array. Now, when we're talking about binary search, which is an application of divide and conquer, first of all, we have seen that a sorted array should be there. Now, a sorted array is given to us. How basically it will work? First of all, we have to see what is a small problem here. Now, let me think here. If suppose you have been provided a single element in your array. For example, in your array, it contains a single element. For example, I am saying that it contains only 10. It contains only 10. This is your single array which is present inside your array. Now suppose your value of key is again equals to 50. So can we say that it is a small problem? Can we say that this is a small problem? Why is that so? Because here if we will see, if we are having only single element and if we are looking for that particular element itself, so it's a very small comparison where we just have to see that is the value which is already present is equal to key or not. If it is equal, then we can return the position which is equals to I, otherwise we can return -1. That's the simple concept which we can do here. So at this point of time, there is no need to use that divide and conquer concept. Divide and conquer will come when we will move towards next step where we are having more than one element. Now, how we can look that if there is a single element, we can make simple condition that if suppose the starting index, which is I, is equal to the value of j. If it is equal to the value of j, where j is, I would say, ending index. So if they both are equal, it means that we are having only the single element. And if there is a single element, we can just make one condition. Now, otherwise, what we can do is that we can divide our array into two halves by calling the mid value, by taking the mid value, which is nothing but is equals to I plus j minus I divided by 2. So in this way, we will be able to generate what is the middle value. So here, what is the value of I? I am considering as a starting index, which is equals to 0. What is j? J I am considering as the ending index, which is equals to 4. So it is something which is equals to 0 plus 4 minus 0 is 4 divided by 2, which is equals to 2. So in a way, I want to say here is that, this is the middle value. Right? This is the middle value which I am getting. Now, once I will be able to get that mid value, I just have to check that whatsoever key I am looking for, is that equals to the mid value or not. So, one condition is first of all we have to check that the key that we are looking for, is that equals to array of mid or not. If suppose they are equal, then it is easy. We can simply return the value of the mid itself, right? But if suppose the key that we are looking for is somehow less than the value of the array of mid, For example, the key, I am looking for is 20. So here if I am looking for a key which is equals to 20, at that point of time, where should I go? Should I go towards the right side of 40 or the left side of 20 to again traverse the elements, to again traverse the subarray? Obviously, your answer should be that for sure the array is sorted. Now you also able to understand why I was saying as the initial case that the major prerequisite is to have the sorted array. Now I hope you will be able to understand. Why? Because this sorted array is helping us to divide the traverse into two halves to reduce the search space. So sorted array helps us to reduce the search space into two halves. Search space into two halves. Either we are moving towards the left or my code will move towards the right. If it is not sorted, at that point of time, that thing will not be possible, right? So here if you will see, if suppose the value of the key is less than array of mid, I know that I should traverse towards the left side of mid. So at that point of time, suppose you have called one function named binary search, where it is taking the array completely, it is taking the starting index, it is taking the ending index, and the value of the key. What you can do is that now you can call the same function again. So here comes the recursion that we have discussed in our previous class as well. So here if you will see, we are calling the same function again, but now we are having the same array, we are having the same starting index, but now the ending index is not j. Why to traverse until j if we know that the element should be present from I until mid minus 1? So why not I will change the parameter of j to mid minus 1, and here I am mentioning the value of key as it is. So this is something that we have understood is known as recursion, where we are calling the same function again but different set of parameters. Now, otherwise, consider the other case. If suppose the key that we are looking for is somehow greater than the value of the array of mid, the same case that we have currently, where I am saying that the key is 50. So in that particular scenario, I am saying that the key is somehow greater than the value of the array of mid. It means my value or my search space should be at the right side of the mid. It means again I'll do a recursive call, but now towards the right side. So I'll call the same function again, but now I will return at starting from mid plus 1 instead of starting from I, go until j, and the key value will remain same. So basically here if you will see, If we are dealing with a very small problem where I is equal to j, at that point of time, it is just taking a constant amount of time, which is order of 1. When I am talking about a big problem, in that particular case also, we are moving towards 3 different conditions. If this condition is satisfying, it will again just a if-else condition. It is just taking order of 1 time, which is a constant time. If suppose the key is less than the array of mid, at that point of time, we are saying that go towards the left subarray. Left subarray, right? So it means that we are dividing our main array into 2 halves, either towards left or towards right. So it is a recursive call. So it is equals to T of n by 2. Similarly, so either I will go for this or my code will go towards this, which is nothing but right subarray. Which is nothing but right subarray. So here, this is also T of n by 2. But the important point here to note is that when we are talking about binary search, either the first condition will be satisfied. So this is the first condition. This is the second condition, right? And this is the third condition. So either the first condition will be satisfied, or the second condition will be satisfied, or the third condition will be satisfied. It's not like that all these 3 conditions will be satisfied. So here in a way, when I'm talking about binary search, so first thing that we have understood is that binary search in an array is applicable for a sorted array. Second thing we have understood that why I'm saying that this is the condition, because it helps us to reduce the search space into 2 halves, either the left part of the subarray or the right half of the subarray. Then we understood the pseudocode or the logic behind how binary search will work. So here basically, if it's a small problem, we can simply just compare that the element is equal to the single array element or not. If it's yes, we can return the position. Otherwise, we can return -1, which indicates that the element is not present in the array. If it's a big problem, then we are dividing into 2 halves by calculating the mid value, and then we are doing 3 comparisons. Here, the important point to note that why we are talking about this left subarray, like when I am saying that the key value, if it is less than the value of the array of mid, why I am saying go towards left, and then in other case, why I am saying go towards the right. So what's the major reason behind that? I hope that the reason is pretty much clear to everyone. I have shown you the example by taking the key value as 20 and then the key value as 50. In both of the cases, you can clearly see from the array itself that where we should go, where your code should go to search the element, towards left or towards right. So it's an example of recursion. So here you can see that how basically we are calling the same function again, but with a different set of parameters. So if suppose, so it's a recursion. So if suppose I'm talking about what is the recurrence relation in this particular case, what is the recurrence relation for this particular case? So you can simply say that it should be equals to T of n, the time complexity, which is equals to T of n by 2 plus C. Why T of n by 2 and why not 2T of n by 2? Because here either my code will go towards left subarray or it will go towards right subarray, but not both. That's the important reason. That's why we are writing T of n by 2 and not 2 times T of n by 2, just like in case of quick sort or in merge sort recurrence relation you will see. Now you can solve this particular recurrence relation by any of the method. Suppose I will show you that how basically we can solve it with the help of a substitution method. So what will happen in substitution method? We try to substitute that recursive part. So if suppose I will ask you that what is the value of T of n by 2. So you will say just try to substitute it. It will be nothing but is equals to T of n by 2 to the power 2 plus C. So if I will try to replace this value with T of n by 2, so we will get T of n as T of n by 2, T of n by 2 to the power 2 plus C plus C. So this is something which we are getting. Similarly, if suppose I will place the value of T of n by 2 to the power 2, so I will be able to get again, just try to substitute this value, you will be able to get T of n by 2 to the power 3 plus C plus C plus C. Now the question is that how many times do we place this particular values. So here we know that the recurrence relation is something where it is saying that when the value of n is equals to 1, it's a small problem. At that point of time, my time complexity will be nothing but is equals to constant or is equals to 1, I can say. But when I am saying that the value of n is greater than 1, at that point of time I am saying that the time complexity will be, recurrence relation will be t of n by 2 plus t. It means that I have to somehow reach to value of n is equals to 1 so that I can place the value of t of n as equals to 1. It means that what I will do here is that I'll try to say what will be the value of the k so that this value is equals to 1, because somehow I want to reach this particular I would say small problem. So here if you will see, you will be able to get the value of the k as taking log on both sides, log of n base 2. This is the value of k that we are getting. It means that when you do the same thing until k number of times, where k is something equals to log of n base 2, you will be able to get the substituted method to t of n by 2 to the power log of n base 2 plus this c value will be repeated log of n base 2 times. Right? Because here if you will see, when you are doing for the first time, you are having single c. Sorry. Yeah. When you are doing for the first time, you are having single c. When you substitute for the second time, you are having 2c, right? 2 times c. And when you are substituting, so let me remove this. When you are substituting for the third time, you are having 3c, right? 3c. Similarly, if you are substituting the values until log of n times, so obviously you will be having log of n times of c. You will be having this log of n times of c. Just following the pattern, above pattern. Now here if you will see, this is something which is equals to t of 1. How t of 1? So here if you will see, I can write it as n by n log of 2 base 2. And this log of 2 base 2 is nothing but is equals to 1, and this is equals to 1 plus c times log of n base 2. Now we know that when the value of n is equals to 1, at that point of time, what is the value of t of n? It is equals to 1. So it is something which is equals to 1 plus c times log of n. Just give me a second. I hope so it was not there. It's okay. So I hope everyone is able to get an idea that at that point of time, so when I am having t of n, which is equals to t of n by 2 plus c. So now when we do it with the help of a substitution method, when the value of k is equals to log of n base 2, we will be able to get the value as t of 1 plus c times log of n base 2. I have showed you how it's possible. Now the overall time complexity is nothing but is equals to order of log of n, right? Base 2. Because when we are talking about order of n, O of n will take the bigger term because it's talking about a worst case time complexity. So that is how basically whenever someone is talking about a binary search and is asking from you that what is the time complexity required to solve this particular approach, it is something which is equals to order of log of n base 2, right? So I hope that the overall idea behind how basically this binary search will work is pretty much clear to everyone. What is the logic behind using that sorted array? Again, I am focusing. Please be clear with that. Don't memorize this thing because in future part of our session, I'll come up with some sort of problems which can be asked from you, but they're not giving as such a sorted array. But then also you can apply the similar kind of binary search approach to solve that part. Try to understand the logic that why we are using a sorted array instead of just memorizing it that whenever sorted array is given, only then I can go for this approach. Try to see the broader picture that what is this binary search is doing for us. I hope that this part is pretty much clear to everyone. With this, I would like to end this session. In the next upcoming session, what I'll do is that whatever I to talk about in this particular session, I'll try to show you the implementation for the same. And till then, bye bye everyone. Do subscribe and share this channel with all of your friends who are in need of all these knowledge. And I'll come back with another important session for the implementation for the same.